So today we're going to look at lesson 7-5, which is on graphing logs. And you will not be able to graph most logs in your graphing calculator. So I'm going to show you how to do it by hand. Your parent function that we're going to be looking at is f of x, which remember is the same as y. F of x is equal to log x. So this is assuming right now a base 10. So not all logs are base 10, which was where the problem comes from. So if you were to graph this, you're going to put this part into the y equals of your calculator and look at your graph. You will find that you will have an asymptote here at x equals 0, and you will have a key point here at 1, 0. So that's your key point. And then your graph is going to hug that asymptote and then go out at an angle there. So we'll look at the table of values later. Then if you go ahead and also put into your y equals 10 to the x, you will get the following graph. And this is what we had graphed earlier, the very beginning of this unit. Remember, you have a horizontal asymptote of y equals 0. You have a key point at 0, 1. And your graph, because this is exponential growth, starts low and goes high. So these two graphs are inverses of each other. So a logarithmic function is the inverse of an exponential function. And remember, an inverse just means that we switch the x and the y. And so if you look at these to each other, inverses when you switch the x and y, these are going to graph. This one will go down here and graph like this. And it'll actually look like it's reflecting over this line y equals x. But you don't really have to worry about that. So the problem is, because you can only graph base 10s on your calculator, you will need to use the inverse exponential function to invert the values. So that's what I'm going to show you here. So I'm going to start by just focusing on the graph, and then we'll talk about how to find domain and range and end behavior and all that kind of stuff. So the first thing you want to do is recognize that your f of x is y. So I'm just going to view f of x as y. You need to put your log function into exponential form because you cannot put a base 2 into your y equals. So we're going to start by putting it into exponential form. So 2 is going to be your base of your exponential form, and remember these two switch. So it's going to be 2 to the x, whoops, not 2 to the x, I just messed that up, 2 to the y, because we're switching them, 2 to the y is equal to x. So that's what we're going to graph, and that's what we're going to put into our xy table. Now because the variable y is in the exponent, we're actually going to choose for y this time. I know we usually choose for x, but remember this is the inverse of its exponential function. And so because we normally choose for x's, the inverse means we switch. We're going to start choosing for y. It would just be easier. So we're going to choose the normal values. There's no movement on this function because nothing's happening inside the function and nothing's happening outside the function. So we're going to choose our normal values of -2, -1, 0, 1, and 2. And so we're going to go to the main menu of the main screen of your calculator. You're not going to be in the graphing function or anything. In the main screen, you're going to be putting the following. So you're going to put 2 to the -2, because that's what our y is. And then you're going to put 2 to the -1, because that's what our y is. 2 to the 0, and 2 to the 1, and 2 to the 2. So you're going to put all of those in. Okay, so 2 to the -2 is going to give you 0.25, because that's 1/4. 2 to the -1 is going to be 0.5. 2 to the 0 is 1, and note that that's going to also be your x-intercept. Why? Because the y is 0, so whenever 0 is one of those, it's an intercept and you have an x value. Then 2 to the first is 2, and 2 squared is 4. So, since we have no up, down, right, left movement, I know that my asymptote is going to be here on the y-axis, which is labeled x equals 0. It's going through the x-axis at 0. We're going to plot the ordered pairs, so we're going to go to the right a quarter and down 2, so that's like a smidge. To the right a half and down 1. To the right 1 and up 0. To the right 2 and up 1, and to the right 4 and up 2. So when I connect these, my graph looks like this. So then let's talk about domain and range. So domain is right-left behavior. So as we start at negative infinity, there is no graph over here. We don't see any graph until we peek over this fence, which is at 0, and now all of a sudden there's some x values. So x values don't begin until after we jump over 0. So our domain is going to start at 0 but not include it and go to positive infinity. Then for your range it goes from low to high. So as we start from low to high, there's a y everywhere from low to high. Everywhere from here to here. There's a y on this side and this side. So it's negative infinity to positive infinity. And if you recall, when we were graphing exponential functions, remember that the domain was always this. And if the log is the inverse of the exponential function, these reverse as well. So now you're going to see the range always being negative infinity to positive infinity. The end behavior, we have to think backwards as well, so it's a little difficult. You have to think of what is y doing and then view what is x doing. So as y is approaching positive infinity, so where is y going up? Y is going up here. It's going up and to the right. So as y is going up, x is going to the right infinitely as y is going up, and so that means that the right-hand behavior for x is going to be positive infinity. Now, as y approaches negative infinity, so where is y going down? Y is going down here on the left-hand side. So as y goes down, x is not going down. X is getting closer and closer to this asymptote, but not actually touching it. So, and you can kind of see that in your table of values. If you look over here, as y gets smaller, x is getting smaller and smaller, and it's going to start approaching 0. All you have to do is put, like negative 10 in for y into here. And if you take 2 to the negative 10, you're going to have a really tiny number close to 0. So as y gets smaller, x is getting closer to 0. So that's your left-hand behavior. Now your x-intercept is at 1, 0. You can see that off your table of values. And your asymptote is x equals 0. All right, let's look at number 2. So this time number 2 has a base of 1/3. So you're going to see the graph looking slightly different when your base is less than 1 versus when your base is greater than 1. So we're still going to do the same thing we did before. We're going to replace f of x with y. And since we have the log by itself, we can put it into exponential function. So start with a base of 1/3. And then I'm switching these two. So we're going to have 1/3 to the y is equal to x. Then you're going to choose values on your xy table. Since we don't have any up or down movement, there's nothing outside here. There's nothing being added or subtracted to the x value, so there's no right or left movement. Our asymptote stays the same. So our asymptote is going to stay here at x equals 0. And so we're going to choose the same values for y, -2, -1, 0, 1, and 2. And I am going to plug in to 1/3 our y values. I'm going to raise that 1/3. So this is what I'm putting into my calculator, into the main screen. So -2, -1, 0, 1, and 2. I'm kind of going backwards. Okay. So negative, or 1/3 to the negative 2 is equal to 9. 1/3 to the negative 1 is positive 3. 1/3 to the 0 is 1. 1/3 to the first is 0.3. And 1/3 to the second is 0.1. So I'm going to plot these points. So to the right 9 and down 2. To the right 3 and down 1. To the right 1, up 0, that's your key point. To the right 1/3 and up 1. And to the right a smidge and up 2. And so this graph looks like it's been inverted or flipped. And I guess in a way it has, because the base has become 1/3. So instead of going in this direction, it's going in this direction. So it's a little different, and that happens when your base is less than 1. So don't think that you've done something wrong. So then let's look at our domain and range. So domain, again, as I start at negative infinity and go towards here, there's no graph over here until I hit 0. Then all of a sudden there's a graph. So your domain is going to go from 0 to positive infinity. And your range, as I go from low to high, there's a graph everywhere, because this is going down and to the right forever. This is going up and approaching 0 forever. So our range doesn't change, and it won't for any of these logs. Then end behavior. So I kind of talked about it a little bit here. On the right-hand side here, y is approaching negative infinity. So as y approaches negative infinity, which is right here, because y is going down, so y is approaching negative infinity, what's x doing? X is going to the right, which is a positive infinity. And then as y approaches positive infinity, well, y is going up here. So as y goes up, x is approaching this asymptote, which is 0. Always one of these is going to be your asymptote. And then our x-intercept, we already got off of our table, is 1, 0. And our asymptote has not moved, x equals 0. All right. Let's look at example 3. Make it a smidge smaller. There we go. So for example 3, and I'm only going to do 2 more of these. So we're going to do a couple of translations now. So now you see the difference. We do have a base of 4, but you now all of a sudden see something happening inside the parent function. So this is inside the function. Remember, inside the function is a right-left direction. So, and it's the opposite of what you think it is. So since we have a -1, we are going to go to the right 1. That means that my horizontal asymptote moves to the right 1. That's going to affect a couple of things, but not a whole lot. There's no up-down movement. I still need to get my equation in exponential form. So I'm going to let f of x equal y. I do have my log by itself, and so I can put it into exponential form. So the 4 is the base, and I'm going to switch the y and the x minus 1. So I get 4 to the y is equal to x minus 1. But this time, x is not by itself. I have to solve for x, so I have to get rid of this -1. To get rid of the -1, we're going to add 1 and add 1. So you end up with 4 to the y plus 1 is equal to x. And so now we're going to choose our xy table. Since I don't have any up-down movement, I'm still going to go ahead and choose my normal values for y, -2, -1, 0, 1, and 2. But what I'm going to put in to my calculator on that main screen is going to look like this. I'll put my exponent here in a minute. And then for y, I'm going to put -2, -1, 0, 0, 1, and 2. Okay, so 4 to the negative 2 plus 1 is 1.1. And then 4 to the negative 1 plus 1 is 1.3. 4 to the 0 plus 1 is 2. 4 to the first plus 1 is 5, and 4 to the second plus 1 is not. No, it's not 9. It is quite the opposite, 17. It's much better. Now I won't be able to graph that one, but I can graph the others. So to the right, 1 and a smidge, down 2. To the right, 1 and 1/3, down 1. To the right, 2, up 0. That's where your key point moved. To the right, 5, up 1. And to the right, 17 is going to be way out there, so I can't graph that. But your graph is going to look like this. All right, so domain and range. So again, your domain, as I start from here, your domain doesn't start until you hit this wall at 1, and then all of a sudden you have a graph. So our domain has changed a little bit. We're going to start at 1 and go to positive infinity. And our range goes from low to high. There is no obstructions, so we have arranged the entire y-axis from negative infinity to positive infinity. And then for your end behavior, you want to look at where y is going to positive infinity. So here y is going up as x is going to the right. So up is positive infinity for y. To the right is positive infinity for the x. So positive infinity. Here we're looking for where is y going down to negative infinity. So here we're going down, but x is getting closer and closer to this asymptote, but not touching it. The asymptote is at 1. So that means your left-hand behavior is at 1. Your x-intercept did move to 2, 0, and your asymptote did move to x equals 1. All right, look at 4. We're only going to do 2 more, so look at 4. This time we do not have a log by itself. F of x is y. Because we have a minus 2 here on the outside of the function, it's not in parentheses, so it's not affecting the x. It's outside the function. That means that we are going to be moving down 2. So I've got to get this log by itself before I can put it into exponential form. So I have to get rid of the minus 2 by adding 2 to both sides. So I get y plus 2 is equal to the log base 3 of x. Now I can put this into exponential form, so I get 3, and then these are switching. So I get 3 to the y plus 2 is equal to x. Now this is already solved for x, so I don't have to do anything on that respect. I do have to make up my xy table. So now normally I would start with negative 2 for y, but because I have a downward movement, I'm going to take my normal negative 2 and I'm going to subtract 2 from it. So negative 2 minus 2 is a negative 4. So the only time we change the values that we choose for y is if we have an up-down movement. So down means minus, so negative 2 minus 2, negative 4. If I had been up 2, up would be plus, so negative 2 plus 2, I would have started at 0. So I'm going to start at negative 4, negative 3, negative 2, negative 1, and 0. You always want to put 0 in there so you can find your x-intercept. And then this is what I'm plugging into the calculator. Let's see, 3 to the something plus 2. I guess I don't have to move it over that far. Let me give myself more room. I'll put the other part here in a minute. All right, so I'm going to have negative 4 plus 2, negative 3 plus 2, negative 2 plus 2, negative 1 plus 2, and 0 plus 2. Okay, so 3 to the negative 4 plus 2 is going to give me 0.1. And then 3 to the negative 3 plus 2 is going to give me 0.3. 3 to the negative 2 plus 2 is going to give me 1. 3 to the negative 1 plus 2 is 3. And 3 to the 0 plus 2 is 9. And so I can graph all of those. Since I don't have any right-left movement, I know that my asymptote has not moved, and so it's still here at x equals 0. And then if I plot these points, I'm going to go a smidge to the right and then down 4. So I'm like right there. A third to the right and down 3. And then to the right 1, down 2. To the right 3, down 1. And to the right 9, up 0, which also happens to be our intercept. And there's our graph. So looking at domain and range, my domain, I start here until I hit 0, and then I have some numbers or a graph. So I'm going to go from 0 to positive infinity. My range has not changed, it's still negative infinity to positive infinity. Then I'm looking for where is y approaching positive infinity. So here we're going right and up, right and up. So as I go up, I'm going to the right as well, so that is positive infinity. The other one has to be our asymptote of 0, but I'm just going to prove it to you. So where y is approaching negative infinity, that's down, and as I'm going down, my x is getting closer and closer to 0, so that's why that's my left-hand behavior. My x-intercept is 9, 0 from the table, and my asymptote is x equals 0. So then we're going to do one last one. I'm going to skip number 5 and go directly to 6, because 6 has both of the transformations up, down, right, left in there. So inside the function we have a minus 2, so inside the function is always a right-left movement. Since it's a minus 2, it's the opposite of what you think it is, so we are going to go right, 2, and then outside the function we have a plus 1, and that affects your up-down movement, and it's exactly what you think it is. So since it's plus 1, we're going to go up 1. So the right 2 affects my asymptote. So my asymptote moves to the right 2. So I'm at x equals 2. And both the right and the up are going to affect my key point. So my key point, which was here, is going to move to the right 2 and up 1. So I bet you we're going to have 3, 1 as one of our points. But first, let's put our graph into exponential form. So I'm going to change f of x to y. And then I have to get the log by itself. So I'm going to subtract 1. And so I get y minus 1 is equal to log base 5 of x minus 2. So now I have the log by itself, so I can put it into exponential form. So 5, let's try that again, 5, and then we're going to switch these two. So the 5 is going to get the y minus 1 up top equals x minus 2. And then of course we have to solve for x, so we have to add 2. And so we end up having 5 to the y minus 1, and then plus 2 is equal to x. So now you can choose your x and y. The up movement is going to affect how we choose y. So normally, again, we choose negative 2 as our first y. So I'm going to add this 1 to my negative 2, and that's going to make me start at negative 1. So I'm going to go from negative 1 to 0, 1, 2, and 3. So I'm plugging those in to my function. So I'll put in the other part of the exponent in a minute. Oops, not. Oh yeah, that's what I want. Okay, so we're going to put in a -1, a 0, a 1, a 2, and a 3. And the value that I'm going to get when I plug it into my calculator is 2.04. And then for the next one, 2.2. For the next one is 3. The next one is 7. The next one is 27. So clearly that one I won't be able to graph. So now we're going to graph 2 and a smidge, and then down 1. It's really close to that asymptote. And then 2.2, and then up 0. That becomes our intercept. And then 3, 1, I told you that point was going to show up. And then 7, up 2. And then that last one we can't graph. And so this is what our graph looks like. So then for domain is going to start at 2 and go to positive infinity. Your range doesn't change. It's negative infinity to positive infinity. And then as y is approaching positive infinity, here's where y is going up and x is going to the right. So since x is going to the right, that's positive infinity. Then where does y approach negative infinity? Here, y is going down, and as y is going down, x is getting closer and closer to 2. So 2 is the left-hand behavior. Then your x-intercept is going to be 2.2, 0, and your asymptote is x equals 2. And that's it. Please try your homework. Definitely come ask questions. Good luck.